Okay. Hi, folks. Thank you for joining us today for part 3 of this webinar series on energy efficient facilities during COVID-19. My name is Annie Smith, and I'm the Director of Energy Services for Ross Baruzzini. Hopefully you were able to join us for part 1 and part 2 of this webinar series. Part 1 was all about unoccupied mode best practices, where we discussed the proper way to put your building into unoccupied mode in the event of a shutdown, like we experienced earlier on this year and could potentially experience again. To assist building owners with this process, we provided a one-page checklist with tips for a successful shutdown to protect your building. And then in part 2, we talked about design impacts of the virus, including UVC lighting, filtration, ventilation airflow, and optimizing Wi-Fi for real-time communication when a building or campus traffic patterns and internet access needs have changed. So today in part 3, we will talk about ways that building owners can counteract the energy penalty from operating their building in, quote, pandemic mode through RetroCommissioning, which utilizes low-cost, quick payback measures to save energy without breaking the bank. Today we have a couple of folks here to talk about this topic. First, we have John Biggs, who is a Senior Mechanical Engineer and Commissioning Agent. John has 24 years of experience in the HVAC industry. He cut his teeth early on in the industry at a consulting engineering firm, then worked as a building automation controls programmer, followed by positions in facility engineering and operations at 2 local St. Louis landmark campuses, the Missouri Botanical Garden and Washington University. He has now come full circle and is again working as a consulting engineer here for us at Ross Baruzzini and has been with us for the last 2 years. We also have Jonathon Bell, who is an energy engineer. Jonathon has 3 years of experience as an energy engineer and building systems auditor. He specializes in finding and evaluating measures to reduce energy consumption and cost in existing buildings through energy audits, including using energy modeling to project energy savings and following up with measurement and verification in the implementation phase to verify those energy savings. We also have Jeff Crawford, the Managing Principal of the Higher Education and Research Market Sector. Jeff has 29 years of experience in all aspects of mechanical engineering and project management, with deep expertise in science and technology facilities, student living facilities, and campus mechanical infrastructure. In addition, he has personally been involved in the design of over 30 USGBC LEED certified projects, 5 of which have achieved a platinum rating and 20 of which have received a gold rating. So our first discussion question today goes to John Biggs. John, a lot of people are operating their buildings with reduced occupancy with the intent to keep the risk of virus transmission as low as possible. What are some items a facility operator or building owner should keep in mind at this time?
Thank you, Annie. Guidance for operating buildings in pandemic conditions can be found in the ASHRAE COVID resources pages. ASHRAE recommends operating the building with as much outdoor air intake as the systems can process and still maintain temperature and humidity set points. So when you're in occupied mode, we want to follow the ASHRAE guidance and open the outdoor air dampers as much as possible to reduce the recirculated air in the building. Additionally, they recommend post or pre-occupancy building purges to achieve at least 3 air changes before or immediately after your occupancy periods. Additionally, they ask for us to upgrade filtration efficiency up to MERV 13, and also to consider various sterilization strategies such as UVC. I always like to point out that the typical UVC application where you're shining a bulb right on a cooling coil to prevent mold does not provide enough UVC intensity or residency time to achieve virus kill. If you're looking to achieve virus kill for sterilization, you usually need a custom install to achieve that. Of course, we've all heard the CDC mitigation steps, and nothing we do with the HVAC substitutes for social distancing, wearing masks, and hand washing, all of which should be considered our first line of defense while we're occupying our buildings in these conditions.
Thanks, John. Many of those recommendations are likely to incur an energy penalty. For example, the added filtration and UVC, and then adding the higher outside air rates will all incur added energy usage. We typically recommend doing a retrocommissioning study to combat this energy penalty. So for our viewers that might not be as familiar, I'll just toss this question over to Jonathan. Can you give an overview of what a retrocommissioning study is?
Sure. First of all, you're correct. A lot of these measures are going to increase the energy usage of their buildings, and that is why we recommend that building owners look for other ways to counteract these energy penalties. To find out how to do that, having a retrocommissioning study completed is a great place to start. A retrocommissioning study is aimed at looking at the building and uncovering ways that building owners can improve operation and decrease energy usage. A study is going to involve analyzing the utility data, comparing that utility data to other similar facilities in a benchmark study, performing a site survey, and then developing a list of recommended measures. Each measure will include a brief scope of work, calculated energy and cost savings, and a life cycle cost analysis. And a quality retrocommissioning study will account for interactions between different measures. So, for example, turning off lights or replacing fixtures with higher efficiency bulbs is going to lower the cooling load in the building, and that in turn is going to affect a chiller optimization recommendation. One of the best long-term benefits of having a retrocommissioning study done is the cumulative energy savings that result from it and the load reduction. By implementing recommendations that do reduce load in your building, building owners can essentially gain that capacity back to their plant. Small measures can save a lot or a little, but doing them in quantity can add up to some substantial savings, and you might avoid spending more on your building down the road for added capacity.
Thanks, Jonathan. So for the next question, I'll turn this to John Biggs. What are some of the low-cost, quick payback energy conservation measures we typically find for owners that want to save energy in their building?
Well, we consider items with a quick payback to be things that pay back in 2 years or less. And of course, that's particularly important right now, but cash flow is always important. Some of the HVAC control measures that we include space level control sequences, such as space temperature setbacks, occupancy-based schedules. If a wing of a building is not occupied, you can set the temperature set point up or down as appropriate to the season to allow the indoor temperature to float somewhat according to the outside air temperature. If you have occupancy sensors, you can reduce air supply during unoccupied times. For example, reducing unoccupied airflow set points helps to eliminate reheat. Typically, what we really target in unoccupied modes is to reduce any simultaneous heating and cooling of the building and to just control to what is required to keep temperature control rather than meeting ventilation requirements for people. When it's an occupied mode, of course, especially now, we really want to overemphasize ventilation. At the AHU system level, we can optimize the airside equipment by doing supply air reset so that we only spend as much energy at the air handler as is required to maintain space conditions and maintain the ventilation rates that we're targeting. Let's see, for example, you can reduce the outdoor air during the unoccupied times and put it back into place during occupied periods. Most people are already aware of variable frequency drives and how those can be utilized to save fan power energy, to modulate the amount of air we deliver to the space. It's important to note that some spaces are driven by air change rates. For instance, educational facilities, medical facilities, what have you, have minimum air change rates. We also take a look at that because the codes have evolved over the years, and specifically a lot of the more recent codes allow lower air change rates and still be code compliant. And in these spaces, they're usually 100% outdoor air. So even though you're reducing the air change rate, you are still providing plenty of ventilation. And of course, many owners have already upgraded their lighting technology to LED, but we can also take a look at things like natural daylighting, installing daylight sensors to modulate the number of lights we allow to come on so that we can use the free light that nature provides us.
Thanks, John. Appreciate it. So since you mentioned ventilation there, some folks might be wondering with COVID concerns how to tackle ventilation in their buildings. Jonathon, are there typical recommendations that would be better to hold off on until we're out of the COVID times?
Yeah, so when it comes to ventilation, we want to be prudent. Energy savings are important, but right now the main objective is to keep our buildings safe. So in normal times, we'd like to reduce the amount of ventilation air whenever possible down to code minimum levels that just satisfy the people and area-based requirements. And this is so that we can minimize the penalty associated with bringing in that outside air. We can do this through demand-controlled ventilation, and this is done by automatically reducing these ventilation levels by looking at either occupancy sensors or taking CO2-based measurements in the space. So during a pandemic, however, we want to take a cautious approach to keep the ventilation rates as high as we can in order to dilute any virus particles that might be potentially hanging out in the air. ASHRAE, in their building readiness article, recommends opening the outside air damper as much as possible, as much as the system or the outside air conditions will allow. Therefore, it's probably safer to temporarily override demand-controlled ventilation schedules. Outside air dampers can still be shut during the night or during extended unoccupied periods. That's still fine, but demand-controlled ventilation is one that we want to stay away from right now.
So now that we've heard a lot about the system level and zone level recommendations, this next question is for Jeff. What are your thoughts on, in the case of a larger campus or group of buildings that share, say, a chilled water plant, what energy savings improvements can we make to those systems as well?
Well, Annie, the nice thing about the central plant side of things is that its operation does not directly impact a facility's risk of transmitting COVID-19 virus between occupants. So we can implement a number of energy conservation measures really without concern for negative safety impacts. A significant amount of energy can be saved in central plants by simply implementing a control strategy that looks at the operational performance curves of each piece of equipment and stages or modulates equipment and adjusts set points to achieve optimal energy consumption based on the interactions of those various pieces of equipment in the plant. In a chiller plant, the chillers, pumps, and cooling tower fans all use power to produce the cooling capacity needed to supply the system. A plant optimization control strategy would look at the resultant power draw of each of these components at various part load and full load conditions and respond by operating the equipment at their most efficient collective state. For example, it often makes sense to operate smaller cooling tower fan motors at higher speeds and a higher power draw to drive condensed water supply temperature down, which in turn creates a greater reduction in power draw from the larger chiller compressor motors. Just as it often makes sense to operate two chillers with VFDs at 50% versus one chiller at 100%, based on their associated efficiencies at these conditions. In short, a central plant control optimization strategy looks to operate the largest energy consumers in the system at their most optimum point, adjusting system set points and the parameters of the other smaller energy consumers accordingly. The potential energy savings from a central chiller plant optimization strategy will vary depending on the size and quantity of the chillers, pumps, and cooling towers, whether or not VFDs are installed or can be added to pumps and cooling tower fans, the load profile of the plant, and the climate. Similar control optimization strategies can be applied to central heating plants as well. It's important to optimize the energy consumption of high efficiency, high turn down boilers by properly staging them and by properly controlling supply water temperature. A common mistake we see is operating central heating plants with high efficiency condensing boilers at a traditional supply water temperature above 160 degrees, which results in a return water temperature that is much higher than the temperature required to achieve condensing operation and those high efficiencies that the manufacturers promote for those boilers. All of this is to say how you control the equipment can have as large an impact on as the equipment itself. Improper operation of even the most efficient equipment can degrade the system efficiency and lead to excessive energy consumption. Altering your central plant control strategy can be an easy, low-cost fix that can yield significant energy savings over the life of that plant.
Thanks, Jeff. That was really helpful. Now, Jonathan, one question for you. With funding being a concern, what are some of the ways owners can look for financing for their projects?
Okay. A good place to start would be starting with the local utility. They typically offer several financing incentives that can be offered for a lot of the low-cost measures that John mentioned earlier. And these incentives will increase the return on investment of each of these measures. So incentives for retrocommissioning studies also exist, and these will pay for a retrocommissioning consultant to come on the site and survey the facility to uncover any measures that could save energy. For example, Ameren, one of the local utilities here, provides electric and gas to many customers in Illinois, and they offer an incentive for retrocommissioning studies. And it covers, in some cases, up to 90% of the study fee. And then on top of that, they have implementation incentives for any measures that you might decide to implement after that. Now, on the other side of the river here in St. Louis, Ameren, Missouri just released additional incentives to approved providers to complete projects through the end of the year. And this is meant to incentivize consultants and owners so that the utility can meet their energy savings goals for the year. Another good form of funding that people can look at is taking advantage of statewide energy loan programs. There's one in Missouri, and it's offered by the Missouri Division of Energy. Their loan program is open through October 30th of this year. This program typically runs on a 3-year cycle and offers low interest loans to cover costs of efficiency projects or renewable energy projects. These can fully cover the project, or they can be used in addition to more conventional financing measures. Another source of funding is the Property Assessed Clean Energy Program, also known as PACE. The PACE program is available to commercial and residential building owners and allows them to facilitate building improvements without needing any large upfront cash payments. The costs for these improvements are paid over time, typically between 10 and 20 years, and these are paid through property assessments, which are secured by the property itself and paid as an addition onto the tax bills owed by the property. Now, since this debt is tied to the property, when a building owner decides they want to sell, they're not required to pay off the remaining balance of this loan. The remaining balance instead will get transferred to the buyer of that property.
That's super interesting. Now, what are some of the benefits of undertaking a retrocommissioning study now, especially in these COVID times, Jonathan?
Well, one positive of these times actually is that since buildings are sparsely populated, this really simplifies the logistics of any survey, demolition, or installation that's going to take place. Implementation costs can also be reduced due to the less need for project phasing related to occupancy, and the timeline of these projects can be shortened as well. Part of an owner's continual investment in their facility should be to include a retrocommissioning study. A retrocommissioning study is a huge benefit because of the resulting reduction in ongoing operating costs, thus improving the organization's cash flow and bottom line. Small upgrades can save immediate capital, and they have excellent ROIs. With proper input from the building's facility team, the study should be tailored to determine the best energy-saving retrocommissioning measures that will give the best return on investment, taking into account the owner's specific investment criteria. Cash saved on utility bills can then be reallocated to support other parts of the organization's mission.
So this next question is for Jeff. Jeff, a lot of folks are wondering about what a new normal might look like and how building design might be affected for the long term. Can you provide any insight to what the future might hold?
Sure, Annie. With respect to HVAC design, there will certainly be a greater emphasis placed on higher levels of filtration and having the ability to deliver higher levels of ventilation, as we've previously discussed. But I also think there'll be a shift away from the traditional large central VAV air handling systems that recirculate air throughout the building for space conditioning purposes to systems that provide once-through ventilation air to all occupied spaces and then utilize local incremental cooling and heating units to maintain the space temperatures. These systems would incorporate a dedicated outdoor air system that conditions and supplies fresh air to all occupied spaces, coupled with either active chill beams, radiant heating and cooling, and or fan coil units that serve each zone to provide temperature control. Additionally, I could see the supply of air to occupied spaces changing from the horizontal turbulent air supply from traditional ceiling air diffusers to a more vertical laminar airflow distribution that reduces the flow of air containing potential virus particles from one person to another. This could be accomplished through either a raised floor distribution system or by using laminar flow type diffusers. The added benefit of these changes in HVAC design approach is that they not only provide a safer environment, but they also reduce building energy consumption. I also see a greater emphasis being placed on the flexibility of spaces and the flexibility of infrastructure in a building. I expect owners will want spaces that can be easily reconfigured to promote social distancing, lower assignable office square footage per person, and the reduction or elimination of spaces that could be densely populated. From a technology standpoint, I envision building technology infrastructure will be upgraded, expanded to ensure there's plenty of bandwidth to support real-time streaming of presentations, as well as multi-directional communication between occupants within a building and occupants that are remote to a facility. And I would expect that building owners will work hard to strengthen their wireless networks to promote the mobility of occupants and activities within that facility.
Thank you, Jeff. So that question concludes the discussion questions I have for today. To summarize a couple main takeaways, while most folks are operating their buildings in pandemic mode, that doesn't mean we all have to resign ourselves to a higher energy usage. By finding low-cost ways to save energy in a facility, we can counteract that energy penalty to keep monthly costs down as much as possible while we ride out the rest of this pandemic. So at this time, I'd like to address any questions we have from the audience. If you would, please go ahead and put them into the chat box. So I'll kick off this question and answer portion with a question to John Biggs. What are some of the ranges of savings that you've been able to achieve in retrocommissioning studies?
Well, we typically like to approach a project with the idea of saving from 10 to 30%. We like to go into a project with a conservative estimate so that we don't overpromise or underdeliver. In older buildings, there's often more opportunity, especially if the building automation system is not being used to schedule equipment. You know, if we have things that are running 24/7 that don't need to, and equipment running at a higher capacity utilization than it needs to, there's often a lot of savings to be had there. As we've been mentioning, conditioning outdoor air is much more expensive than recirculated air, so we take a look at that and try to find ways, especially in unoccupied periods, to reduce the outdoor air intake. A good example of a project we did recently that demonstrates the earlier discussion about air change rates is we did a laboratory with a local university. This laboratory had been designed, I believe, back in the 1990s as a wet lab, had 12 air changes per hour programmed, and the usage of the space had morphed to more of a dry lab application. And the new codes allowed us to go down to 6 air changes. We were able to knock the energy consumption down by 37%, both on paper, and we also did a follow-up with the owner and verified that those savings were actually occurring. As part of that, we redesigned the system to go from constant volume to variable volume so that they could also have unoccupied air changes, which code allows to be less than the occupied air changes, even for laboratory or medical type spaces. I believe we also did some integration of the lighting system into the occupancy sensors to make sure to reduce our lighting load and energy consumption as well. So it gives you an idea of the kind of things we typically look for and some of the savings that we can achieve.
Awesome. Another question we have here, I'll send this one over to Jonathan. Okay. What are some of the things the owner would need to get started with a retrocommissioning project?
Okay, yeah, so what we would like to see before starting a retrocommissioning project typically would include historical utility data going back maybe 2 or 3 years, either Excel or in like scanned PDFs are fine. Those formats are great. And what we'll use these for is we will do like a pre-benchmark of the building, just kind of see where the building's operating at on a square foot basis, and that enables us to know what we could expect whenever we walk into a facility and what type of savings we could be looking at. The next component that I would say we would need to start is a set of mechanical, architectural, and electrical plans. These will help us on the site visit to kind of know where we're going in the building, just so that we don't get lost. And also having the mechanical and electrical plans will enable us to plan out the site visit, and so that we know which areas of the building we'll want to hit up based on what equipment is in the space, what size everything is, things like that. So.
Okay, awesome. Thank you for that. We have another question here. What would be the typical cost of retrocommissioning? Jeff, do you want to take that one, or I can handle that as well?
Well, Andy, as you know, we've put together a number of these proposals. It varies. It depends, which is the answer no one wants to hear. But for large buildings with a lot of duplicated spaces, we've done some of these studies. I think the lab building that John Biggs mentioned was less than a quarter a square foot, up to smaller, more complicated buildings, 50 cents a square foot. So I want to say, and Andy, correct me if you disagree, but I think I would want to say between a quarter to 50 cents a square foot is probably a good number for a comprehensive retrocommissioning study.
Yeah, I would agree. If I could add on to that, it also depends on like you mentioned, the complexity, and if there's a robust building automation system in place, and if there's accurate trend data that we can call upon already in place, that tends to help us out a bit and get the cost down a bit. Mm-hmm. So with that, if there are no other questions, I will go ahead and adjourn us for the day. If you have any other questions that you think of later on, please feel to reach out. Thanks again for joining me today, guys, and running through some of these discussion topics. And thanks to all of our attendees for joining us. I hope this discussion was useful to you. This session will be recorded and posted on YouTube, where you can find more helpful videos on the Ross and Baruzzini channel. So thanks everyone for attending, and enjoy the rest of your day.
Thanks.
Thank you.
Thank you.